So here I've got it all set up now, so tubes, rad and the core box are all plumbed in. Here's a closer look at the CPU block. You can see the RGB LEDs on the side there. I haven't turned it on yet. So got the pond pump in the core box, and we have got the 1080 radiator. We've only got the CPU in the loop at the minute just to test it out. And all I'm going to do is I'm just going to go underneath the desk and turn the pump on and off a few times, see if we can get some air bubbles out. So it seems okay, we don't have any air bubbles to be fair. I didn't see any go through the outlet tube there. This one's going in, that one's going out. So yeah, it's looking pretty good. You can see through the top of the block really well as well, which is nice once it's got the water in there all nice and clear. It does not seem to be leaking, although I have not been running it very long, so probably wouldn't notice a drip if it had a minor leak for a while. But it looks okay for now. All the seals on the inside look okay, so we shall carry on, boot her up, see how it goes. Now for the CPU fan, obviously with a water block you're not going to need an actual CPU fan on your heatsink, because obviously you're using a water block. However, for X399 or X299, your VRM is going to get absolutely roasted if you just leave it. Maybe not if you have a rad right above it, but if the fan's really on 800 RPM, this heatsink is going to get pretty toasty, especially when you start putting some voltage through it. So we've got this bendy fan over here, and all I'm going to do is basically bend it to there and plug it into the CPU fan header. There we go. And I'm going to try and actually orientate it so it isn't hitting against the thing here, because it'll annoy me. It's not screwed in very well either. I might just tighten up a bit. There we go, that's better. A bit tighter now. Not going to wobble around as much as before. So we're going to have a fan pointing at the heat sink, and you actually don't want the motor pointing at the heat sink, you want the open bit at the bottom of the fan, because then what it's going to do is it's going to blow out the air across the heat sink and across the board and just general board area as well, which is obviously better for the board. It's got a bit of airflow going over it, even in a water cooled rig. So you have to consider these things. You're going to be pushing more power through the VRM than air, and you're going to have less airflow than air, so you do need to remember to cool your VRM with a fan. So let's fire her up, see how she goes. It should be at 3.8 THz. Oh my days, there is the RGB. Oh my god, that is very, very offensive. Wow, that is like a rave. Look at that. Full disco party mode right there. That is awful. So, what we're going to do is, before I die of like epilepsy or something, while the rig is turning on, we're going to try and get into the BIOS as well if we can. There we go, it is in the BIOS, and we're going to check the temperatures, but first I need to turn these LEDs off this thing. This is awful. So, what happens if I press this button? It's slowed down, so it's less offensive. That's red, blue, green, red, blue, reddish, different red, blue, blue. We'll go for all the different colours, screw it. It's got a button on the thing, I can just press here, go for a load of different colours. So that's a lighter blue, that's a nice greeny colour, sort of a paler green, that's sort of a yellow, yellow, red, red again, white. So that's full white, and it's actually quite white actually. For RGB LEDs that is pretty white, because usually they're a bit pinky or a bit blue, and that is not too bad at all, I have to say. That's probably the best RGB white I've seen. It's a little bit pinky maybe, but yeah, it's pretty good actually. Quite impressed with that. Sort of a pale blue. To refocus you again. That's the red, blue, green again. So I think I'm going to keep it on the red, because obviously we're on Threadripper, and the board's all breathing red, lighting up red, as you can see on the chipset heatsink. So I think we're going to keep the red for now. We like the red. So, on the screen, tripod, come on. We'll just move it across a little bit. Oh, there we go. So smooth. So smooth. Oh yes. Superb. So we're going to go into the hardware monitor first and check our temperatures. So the fan is spinning at 2000 RPM, and you can just hear it. It's not actually too loud, but it's alright. The CPU is 16 degrees. Now the reason it's 16 degrees when the room is clearly 22 degrees Celsius, and oh, I can even do for the American people 72 degrees Fahrenheit. Oh god, that is awful. Stupid Americans. Anyway, the reason why the CPU is so much colder is because the the water in the cool box that the pump is pumping round is straight out of the tap. So these tubes here are basically tap water temperature, which is about 8 degrees Celsius. 8 to 10 Celsius normally in the UK. 6 degrees outside, plus or minus a couple underground. So we are just going to boot up at the normal bog standard settings. So we've got 3200, 14, 13, 13, 28, 1T with the 68 and the 320. Now we booted up quicker than this before, but we're just going for some safe settings just to make sure the water block's seated properly and everything is all good. So there we go. That is a fine looking water block, I have to say. That is a really, really good... Oh yeah, that's a nice deep red on the camera there now. Hopefully that will show up in the video. But that is what it actually looks like in real life, but slightly lighter because my eyes are better than the camera. But it's that kind of deep red, that AMD red. Well, it's still booting into Windows because it takes ages because of the amazing single channel ROMs. But yeah, that is a damn nice looking water block, is that. And the good thing is as well, I was actually a bit sad because the water block was copper. But once you put the LEDs in there, you can't tell that it's not a nickel water block at all. It just does look like a nickel or copper block. It doesn't actually make a difference. So yeah, that looks properly nice, does that, I have to say. Oh, all the AMDs, all nice and red. So, now I don't have any temperature monitoring software for Ryzen on this PC. So it's kind of a fail. What we are going to do though is we're going to go up to 1.4 volts on the CPU, regardless of what the temperature is at. And yeah, we're going to see how fast it will run Cinebench at 1.4 volts basically. That is my arbitrary limit for today. So yeah, I don't know what's with the dodgy screen resolution. I suppose it's a bit easier for you to see. So we'll start with a classic change in the background colour so you can see better, and it helps the camera focus better as well actually. So yeah, that is a lot better. And you're a bit sideways, but you don't care. Well, you don't have a choice actually. Not that you don't care, but I mean it's either sideways or no video. So there you go. So let me just zoom in with my amazing digital zoom. You can see there 3.85 trigger hertz, and we'll do a quick run of the Cinebench before we restart because it's found the GT710. So we'll just do a quick run, see what we get. Now I have got some baseline scores over here already. That was with the memory slightly faster though. So there we go. 3100. And that was at the exact same clock speed, but with faster memory we got 3258, which you can see there. So I'm recording this video in 1080p as well, because last time I was an idiot and I was recording in 720p, 120 FPS for the entire video. So that was a massive fail, and I just pressed shut down, which is also a massive fail. So what we're going to do is, I think we're going to start at 1.35 volts, just so we don't warm the water up too much to start with. And we're going to see how high we can go at 1.35 volts first. So we'll get an idea of how this chip scales. At the minute it's on at 1.24 volts, I believe, ish. 1.2375, you can see that there quite well actually. Camera's doing a good job today, I have to say, for once. So we're going to try probably 3.9 at 1.35. Oh my god, 1.7 volts, definitely not. If only I had some LN2. So, screw it, we'll go all the way up to 3.95 just off the bat. See what kind of performance boost we get. Zoom you out a little, there we go. So, it is booting up. And still looking exceptionally red. I love that red, it's beautiful. Might go through some more colours though again. See what we've got here. What do the other buttons do anyway? What's that button do? Well, that button controls the brightness. So it gets brighter. Oh, and then dim. Bright, 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 dim. 1, 2, 3, 4, 5, 6, 7, 8. So it has 8 settings. 1, 2, 3, 4, 7. Okay, so I'll put it on the top one. And oh, that's a nice bluey colour. Very nice. That's more of an orangey colour, but it looks red. That's definitely orange. That's like a nice Gigabyte SoC Champion orange. But again, looks kind of red. That's red. That's red. That's blue. Quite a nice sort of sea blue. It's not too dark. It's a bit of a brighter blue. That's a very pale blue. Green. Sort of a yellowy colour. Then we're back to reds. White again. Not too bad, not too bad. And then the blue. And then the solid red again. We'll keep it the solid red. I like the solid red. Solid red is good. Wow, as if I'm actually enjoying RGB lights. Thought my intelligence was above that, but clearly not. So let's have a look here. Just checking the CPU Z that we're at the right sort of speed area. So let's have a look here. Oh no, camera, you're failing me. It's because the resolution's higher actually. We'll lower the resolution down again for you. 1024 by something. Is it 1024 by? It wasn't 1024 by 768. It was 1280 by whatever. So you can see the CPU Z better now. There you go. So we're at 3.95, and the voltage is still at 1.25 volts for some reason, even though I'm pretty sure I set 1.35. But what we'll do is we'll run Cinebench, and if it runs, we'll say hooray. So what I'll do is I'll put this in front so we can see the voltage. It's apparently still at 1.2 volts still. Oh well. Whatever. Now the power consumption is... I totally missed that. I'll have to run it again. Close CPZ. About 300 watts, 290-ish. So that's pretty good actually. Yep, 290 watts, and it isn't scoring particularly well because obviously the memory is not very fast, so we need to sort out this memory back to where it was. So we're going to boot into Windows with the RAM now at the correct speed, which is 3466. Water's probably warming up a little bit now. Tubes are getting sort of room temperature. So let's have a look on the CPU Zs and see if our memory and CPU are now running at the correct speed. And sure enough, 3.5, or not 3.5, 3.95 trigger hertz. And yep, memory speed is now correct. Woohoo! So we can run a little Cinebench and see how she goes. There we go, going up now, 3201. Can't see us getting another 50 or 60 points though. Maybe we need to run it in real time. Helps quite a bit with Threadripper actually. Seems to be a 1% CPU usage as well for some reason. End Explorer here. Damn it. So, Cinebench, set priority, real time, change priority, and you want to make sure you're in administrator mode before you do that, by the way. So you want to untick these two bits, file, or put it in the corner, file, run all selected tests. Then in this case I'm going to watch the power meter on the wall, and I'll be able to tell when it's done because the wattage will go down. So it's just finished. So I'm going to run it a few times. So you can see it's still red. It's definitely not any less red than it was before. Beautiful red. Very nice deep red. It's finished again. Going to run it one more time. And it's done. So we got 3217, which isn't actually that brilliant. I think I might have installed a I've got both AMD and NVIDIA drivers installed in here, so we need to do some DDUing. Hopefully, yeah, we have display driver uninstaller on here. Very nice. Now I want it in safe mode, because if you don't do it in safe mode, it actually conflicts with the AMD chipset drivers. So I've now got rid of the GPU drivers. So what we're actually forgetting here is the cheat settings in the BIOS. So the memory on Threadripper can be configured in various different ways, and so I'm guessing that is what's making the Cinebench score low, not the actual drivers themselves, although they could be, so we've uninstalled them now anyway using DDU. But we also need to set up the cheat mode or whatever it is. So yeah, you can see here the performance regulator or cheat regulator needs to be set to R15, and that is all that was giving us that terrible performance all that time. So yeah, pretty amazing how much difference that makes. So we'll just set it to that and boot back into Windows. So we have managed to get back into Windows on my nicer blue screen, and we'll check the CPU is running at the correct speed again, which hopefully it is. There we go. And it's still reading 1.24 volts for some strange reason, even though it's at 3.95 gigahertz, and we'll just check the memory is the correct speed as well, because that would be a good idea. So the memory is at, yep, so that's all good. So this time if we run Cinebench, it should automatically be better, purely on the basis that we set up the cheat thing. We've uninstalled the graphics drivers, so it should all be good now. Still using 290 watts. Only using 150 watts now. Looks like it's crashed. So we'll wait for it to blue screen. Still using 150 watts. So I'm guessing that the voltage is still at 1.24 volts and not 1.35 like we actually set. Which is interesting. Maybe we set the wrong voltage. CPU core voltage 1.35. Load line calibration. Modes. Wow, that is so helpful. That is not helpful at all. Why can't they just put low, medium, high? Then you know which one's which. Mode 1 to 8 just means absolutely nothing. So the core voltage is definitely 1.35. So I do not know what's going on there. We'll change it to 1.375 and hopefully it actually sets the voltage right this time. Could also be CPU-Z's not reading it correctly. That is possible. There we go, 1.38 volts. So it has actually set the voltage this time. It's nice. We'll open CPU-Z as well so we can keep an eye on it. And it should use a few more watts this time, hopefully. Right, let's run it, see how it goes. So yeah, right off the bat it's using 360 watts. That is definitely more like it. So it's probably getting pretty toasty, and as you can see we've got our second highest score straight away. So that is more like where we wanted to be honest. Before where we were was not very good at all. So we'll give it another couple of runs and see how she goes. It's pretty quick to run this, which is nice. 3,266. So it's increasing nicely, very nicely indeed. So what we'll do is get the damn task manager open, get rid of Explorer, set the priority to real time, real still, and yeah, here we go. So we'll get rid of the CPU-Z. And what I'll do is I'll bring you down to have a look at the power consumption. So we're at just under 1.4 volts. Get the torch. Get my chair down a bit as well so you'll be able to see it. There we go, because otherwise the chair will be in the way. So, at the moment it is idling at 90, about 100 watts, we'll call it 100 watts. So I can prop the camera up with the thing. No, I can't. Let's just decrease the brightness a bit. So, we'll start the test here. File, run all selected tests, and you will see, there we go, 360 watts. And this is at the wall obviously, so the CPU isn't pulling a full 360 watts. And you'll see when it finishes the test, it goes back down to 100 watts. So we'll run it a few times, probably 3 or 4 times. Look at that power. Yes. Now that is proper thread ripping performance. It's still half as much as like an Intel i9, but it is a fair bit of power, is that, to be honest. But like I say, it's nothing compared to an Intel i9, which will probably be drawing 1000 watts at this kind of voltage, because you can only really go up to like 1.2 volts on those. So I just want to run it one last time here at 3.95, and then we'll try for 4 trigger hertz, and we'll see what the score is at this. Oh, it's taking a bit longer this time. There we go, 90 watts. So now we've seen what it pulls from the wall. Let's put you back on the tripod there. There we go. So let's see what score we got. 3,292. That's not too bad, it's nearly 3,300. Which is not bad considering we're running single channel memory. Now if I can find the right USB stick, we shall plug that in. It's already in. So I'm actually going to screenshot this now. It takes so long to reboot this. It's almost like having an Asus board, apart from it's just a Threadripper instead. So we're going to go straight for 4 GHz. I'm going to leave the voltage the same, obviously. Still got a little bit of room on the SoC voltage as well, so we might be able to up the RAM a bit later on if we get stuck in terms of megahertz, which we obviously will because it's Ryzen, or Ryzen based, so we'll get stuck probably around 4.05 or 4.1ish, I reckon. Right, okay, we're in Windows and we are at 4 GHz, there it is. Still 1.375 volts in the BIOS, still the same memory, frequency and timings and all that shenanigans. So we're going to run the Cinebench R15 again. Pretty quick. Obviously we're going to break 3300 at some point this time. So we'll need a few runs obviously to get the Ryzen up to speed, get its AI learning. Still using about 360 watts on the power meter. There we go, 3,300 exactly. Very nice. So fast to render the whole thing, it literally takes seconds. You can run it like 5 times within 2 minutes. It's amazing. 3,313. She just keeps going faster and faster. Beautiful. So we'll ditch all this shenanigans. Oops. CPZ's fallen behind. Not CPZ. The task manager, sorry. So we'll go real time again. Now watch the power meter. And you can watch the PC, because it looks pretty cool. Maybe a bit of a higher vantage point there. There you go. How about that, eh? There we go. Unfortunately there isn't much to see on a water-cooled rig, because obviously nothing moves, but yeah. It does look really, really nice. It's finished already, it's so fast, it's crazy. And you just mess about for 2 seconds. Now in real time, interestingly, it's pulling slightly more wattage, so you can tell that the CPU is going slightly faster. Pulling about 370 watts when I'm running it in real time, opposed to about 360. So you're getting that extra 10 watts of power just by running it real time. And that extra 10 watts is pegging the CPU at 100% to the point where you can't even move the mouse on the screen, like the mouse freezes. You can't do anything at all. So it's using all of the CPU to squeeze every single last point out of the score, which obviously means you get a higher score overall, which is good for hardware bot. It's a little bit blown out, is that image? There we go, that's a bit more natural. And it has actually crashed on the 5th run, I think that was. So let's see if we can actually... Can't do anything but close the program there, unfortunately. That is a shame, because we never saw what score we got. But we did run it a good 5 or 6 times before it crashed. So I don't know what it got there. It's probably just needs a little bit more voltage. So 339, and that's not in real time, but it's obviously run it a few times before, so it still knows what it's doing. So if we just run that in real time now, again, let's try and get it not to crash. So it's not 100% stable at these settings, but we only need it to be stable just to run Cinebench, just for the screenshot. So we'll see if it can run it in real time again for us. Now interestingly, when it crashes, sometimes it only goes down to 150 watts, and because it was pulling 300 watts and it's going down to 150, that's sort of telling me that one of the dies in this Threadripper, which obviously has 2 working dies, that one of the 8-core dies is weaker than the other 8-core die, and it's almost like one of them is still going and the other one's crashed. So it has finished, so we'll see what it's got. So it's still getting 339, so we'll go with that. That's pretty damn good, I have to say. So we'll take a screenshot, restart again. Let's give it a bit more voltage, a bit more speed, but 1.4 volts, 4 gigahertz is usually where I'd run my 1800X to be super stable. Now what I usually run for 3D benchmarks and most 2D benchmarks on the 1800X is actually 4.1 gigahertz, but at 1.475 volts, which is quite high voltage. But obviously, because that's only got 8 cores, it does run a bit cooler. Now this camera's at a kind of annoying height where it's trying to fall down out of position all the time. I could just zoom out, there we go. So, we'll try 4.05, but the full 1.4 volts now. So, that is like the voltage cap that I've arbitrarily set myself with no temperature monitor, because obviously I don't want the CPU overheating. There you go, 1.4 volts. It's actually reading 1.408. And 4.05 gigahertz. So, see if it'll run Cinebench without crashing. Because obviously last time we did get a little crash, but after we ran it a few times, to be fair, so we'll see how it goes. It didn't fully blue screen either, it just actually had an application error, which could mean we just want a bit more SoC voltage. So right off the gate we've got 3365, which is much higher than our other score, so that's good. It's just with an extra 50 megahertz as well, so that is very good indeed. We are in the Cinebench cheat mode as well, so 3365 again, so it didn't learn the second time. So run it 3 times normally, then 3 times in real time, and see how it goes. And that's it. Done. Amazing. There we go. 3,392.